So earlier we've talked about what reactive programming is. I discussed this in the context of the completable futures framework. As we talked about, completable futures has many properties of reactive streams, but it doesn't really go quite as far as we would like it to go in order to be able to provide built-in support for reactive streams from top to bottom. Instead, you have to integrate it with Java sequential streams. So what we're going to do today is start by talking about how reactive streams works. And we're going to focus on the Java Reactive Streams application programming interface. We'll also talk about a couple of patterns that are crucial to understanding how reactive streams works, and you'll see how these patterns collaborate in order to be able to provide the abstractions that reactive streams gives you as a programmer. Speaking of abstractions, there are several key abstractions that are important to understand reactive streams, including publishers, subscribers, and subscriptions. And we'll also talk briefly about what all those different key abstractions do. So let's first start by talking about what Java supports in terms of reactive streams. So starting with Java 9, it began to support the reactive streams model with something called the Flow API. And you can learn more about the Flow API at the link at the bottom of the slide here. It also provides support for stream-oriented publish subscriber patterns. So you'll see here that this allows the subscribers to inform the publishers how much data they can accept, and then the publishers can then send that amount of data to the subscribers. And as we'll see, it supports two patterns that are combined together to provide the reactive streams programming interface. The first pattern, which is from the so-called Gang of Four book, is the iterator pattern. And this is used to apply a pull model where the application subscriber or subscriber components can pull a certain number of items from a publisher, which is the source of the items. And you'll see the other pattern, which is also from the Gang of Four book, is the observer pattern, which applies a push model that reacts when a publisher source pushes an item to one or more subscriber sinks. So we've got sources, which are publishers, and we have subscribers, which are sinks. They handle the data, they consume the data. And this, of course, is based on the iterator and observer patterns. The Java Flow API defines a set of interfaces that are designed to ensure interoperability of different implementations of the Reactive Streams API. And you can see that there are basically four of them: publisher, subscriber, processor, and subscription. And we'll talk about each of these as we go through the different examples and other illustrative case studies. So the flow that occurs between the different elements in a reactive stream involves interactions between three key elements or components. The first is the publisher, and there could be one or more of them or zero of them. And there's sources that produce zero or more events that can be pushed to zero or more subscribers. This zero or more theme comes up a lot because there's nothing that requires there to be any publisher or subscriber, although in practice there typically are at least one of each. Subscribers are sinks that register for and consume the events that are pushed by one or more publishers. So they are the receivers or the recipients or the consumers of these events. Publishers can push events to the subscribers that register with them by invoking so-called hook methods, which are just virtual methods that can be overridden in various ways by either the Reactive Streams infrastructure and or by application developers. And you can see that there are three primary hook methods: on next, on error, and on complete. You can also see there's a little regular expression here that illustrates what types of events can flow. There can be zero or more calls to on next, followed optionally by either one on error or one on complete event. The subscription is an abstraction that's used to control the flow of events between a subscriber and a publisher. So what happens is a subscriber uses the subscription to indicate to the publisher how many events it can handle before it needs to reinform the publisher that it's ready to handle more. And this is typically used to support something known as flow control. And you can see here that flow control would allow a subscriber to say to the publisher, please send me up to 3 requests before I turn around and request the next tranche or the next chunk of requests, the next N requests. So how things work here is a subscriber starts by subscribing to a publisher, requesting the publisher to start sending it data. Before the subscriber subscribes, nothing happens. A reactive stream is therefore lazy and it only starts to do anything when subscribe is called. Before that, it doesn't do anything at all, which is a bit like the way that terminal operations work in traditional Java streams, where the stream is passive and lazy, and so nothing happens until the terminal operation is reached. The publisher then calls back on the subscriber using a hook method known as onSubscribe, and that gives the subscriber a chance to indicate to the publisher how many events it can handle before it has to request some more. So typically, the subscriber will request a certain number of events, and again, no events are sent by a publisher until the subscriber signals its demand using the request method. There's a couple of different ways to use this. One is to give it an n, like 5 or 10 or 20 or whatever. The other is to give it a maximum value, like max int or max integer value. And in that particular case, the max value of int would be used, or long would be used, to indicate that there is no flow control, and the publisher should send data just as fast as it can and as much as it can. The next event type we'll talk about is the onNext hook method. And this is a data notification hook method that's called by the publisher when it receives events, or when it obtains events, or when it generates events to be sent to the subscribers. And there can be 0 or more of these onNext notifications, which form a stream. So you have a stream of onNext notifications, or not. You don't have to send any if you don't want to. When everything is finished, when the last event is sent through onNext, then the publisher can indicate it's finished by sending the onComplete event, which indicates to the subscriber that it's all finished. And that can also be used to free up resources after onComplete is returns. OnComplete, you can think of OnComplete as something along the lines of end of file, if you're familiar with the way that the Unix command line works. And you can send an end of file character, or Unix file works, indicating we're all done. There's also another hook method, which can optionally be called, known as onError. And this can be called at any point along the way. It could be called right away, it could be called at the end, it could be called in the middle, doesn't matter. And that indicates to the subscriber that the publisher has identified some error, and it conveys that error by throwing an exception or conveying an exception. It actually conveys a throwable, which is a base interface of base class of the exception class. So that's the end of the overview of the Java Reactive Streams API. And of course, right now you probably couldn't write a very interesting program because we've only covered the basics of the flowable API and flowable interfaces. But we'll talk a lot more very shortly about how to use these things in practice.